Remember our test, Wednesday, 8186. Calculator, non-calculator.
What happens when you do all the sections?
You know, with the, I didn't want to do all the sections for the test because the last little bit of 8.7 and 8.8, it's not a lot of material, but in order for us to fit it all in prior to, because we have a shortened week this week, I just don't, there's just not enough time. So we'll just have that be like its own little standalone section. It won't be that big of a deal. We'll tack it on to the next unit. Yes, ma'am?
Is the non-calculator part going to be longer than the calculator part?
No, it's pretty even. It's pretty even. Think about calculator, non-calculator. Non-calculator is group graphing. Some of your simplifying, expanding, condensing. You can do all that without a calculator. The things that you'll use the calculator for is going to be kind of what we're working on today, as well as like those word problems with the compounding interest type things that we've done in the past. Okay. So we'll do that stuff as well. Yeah. What's that? The graph, yeah, graph exponential growth, decay, and logarithms. But you guys did exponential growth and decay, which is pretty easy. It's just making the silly mistakes with your negative exponents. Logarithms, you found that it's just the log base b of b and log base b of 1. So it's pretty easy. So let's just jump right into solving the equations. Solving equations work with logs is actually extremely simple. There's only a few things that we wind up having to do. And I'm kind of going to give you guys an example of just about every one of the styles we have for today and how to solve them out. When we've been working with these in terms of bases and exponents, we've been kind of working through some of the rules of how your exponents are able to come down by either exponentiating the problem or by taking the log base on both sides. That's what allows the variables to drop. What's happening here is that in order for you to solve an equation when you have variables as an exponent, you have to have the same base. Once you get the same base, that means the exponents have to be the same. So in an example like this, I have, 4 to the 3x and 8 to the x plus 1. What would be the common base that I can get them both in? 2. So I can get these both as a common base 2. So this
when
becomes,
you get the common base, the base is just not.
yeah, I'll show you why.
It's not a joke.
Oh, so there we go, like, you're making sense.
So notice how you get the same base on both sides here. This next step is implied, but you don't need to show it. The reason that you can do what we're about to do is the following. To get the exponent to fall, I'd have to take the log base 2. Log base 2 of 2 of whatever that is makes that come down. Remember when we did those simplifying back in 8? Yeah. But what you do, since it's an equation, whatever you do to one side, what you have to do to the other.
The opposite.
Same thing.
So put in the log?
So you have to put the log base 2 on both sides. By doing that, it allows the exponent to come down. This is a step you don't need to show. Because you have same base, that means you just get 6x equals 3x plus 3. Solve for x. You get 1. What?
So
Okay.
Not bad at all.
So plus 1 on the exponent and the 8x plus. Okay.
Yep. The only thing you guys a lot of times will screw up when you're doing stuff like this is you're going to forget to send it to the 3 over the 1. That's usually where you're going to screw up. So just take your time. Okay?
It's not bad at all.
No, it really isn't. You want to get these common bases. So let's just look at this one. I'm going to go ahead and get a common base. I got 9 to the 2x equals 3 to the x minus 6. What's the common base I'm looking for?
3.
3. When I do this side, I get 3 to the 2 times 2x equals 3 to the x minus 6. Do you have the same base on both sides?
Yes.
Drop your exponents. 2 times 2x is? So you have 4x equals x minus 6.
So it equals,
x is -2. Now remember, you have calculators when you're doing stuff like this. You could substitute those values back into your original to see if they're true. And check it. Yeah, that's the straight is. You'll have to look for them. It'll say that. What were you going to say?
I was gonna ask if you.
Yeah, eventually we'll have the straight is, but we're just getting going. Like I said, this should not be horrific.
It's not.
When it gets into having to work with different bases, you have to do one extra step. 2 to the x equals 7. Now I can't get them into the same base. How do you get that exponent to drop? You take the log base 2 of both sides. So x is the log base 2 of 7. I bet you there happens to be a button on your calculator to do that. Alpha window 5, I believe. Yeah. And you get a decimal equivalent. Go 2 decimal places. What do you get?
2.81.
2 decimal places?
2.81.
Very
So do you want the decimal answers or do you want like exact?
No, decimals. I'll say round to the nearest hundred. It's normally what I set for these things. All right. That's usually my standard round these. Oh no. Multiple steps.
You.
Ew. Think about your order of operations. When you're doing your order of operations, if you had to, you work backwards when you're solving equations. So if I have 10 to the 2x minus 3 plus 4 equals 21, what will you do first? Okay, subtract the 4. So we have 10 to the 2x minus 3 is 17. How do you get those exponents to drop? Log. Log base 10, or log base 10 is just log. So you log both sides. So you get 2x minus 3 is the log of 17. Log of 17 is just some crummy number. You agree? Now, in order to get x by itself, what are the other two things you would have to do? Subtract 3. Add 3 and divide by 2. So we all are in agreement that x will equal the log of 17 plus 3 all over 2. Now I want you guys to see what happens when you press the button that says log. What opens? So what should close after you type in 17?
I'm guessing parentheses.
I'm guessing you are right. 216, or excuse me, 212.
How do you put in everything into
Alpha y equals? And it works. Fraction. It does the same thing. So, like I said, the trickiest part here is remembering to close the parenthesis. It's not scary. You've checked your phone 7 times in the past 2 minutes.
Mom.
Put your phone away. You're in school.
Okay.
Seriously. And your mom should know that.
I'm asking you a question.
You can wait. Do this one. You're right, it equals a tenth. Can't you just take the log? Bless you. Log of 0.1, put it in your calculator. So if you have 3x minus 4 is the log of 0.1, add 4 divided by 3, you should get 1.
You know, we have all the rules and stuff. Like,
Think about what this is. What is 0.1? It's the log base 10 of 1/10. 10 to what power is 1/10?
That's what I was trying to
Yeah,
get.
and that's where it comes from, okay? So it's -1. Add 4 divided by 3, you get 1. Okay? What about this?
natural law or something.
They do. Let's take a plus 1. So we have 2/3 times e to the 4x plus 1/3 equals 4. Well, before we even do that, let's just get rid of the, you can subtract a third if you want. Make your life easier. Get rid of the fractions. What are you going to do? See how since this is an equation, just multiply everything by 3. Get rid of the fraction. If I do that, it works out a little bit cleaner. It's just easier to write out. So we have 2e to the 4x plus 1 is 12. You okay on that? To get the e to stand alone, subtract 1, divide by 2. Are you okay on that?
Yeah.
So I get e to the 4x, which is 11 over 2. Now, relate this problem to any other numerical value as a base. You log base it on both sides.
You messed that up at 6. And then,
Because you subtract 1.
Subtract 1 and divide by 2. Yes.
oh,
Now, if it was 2 to the 4x, you'd log base 2 of both sides. If it was 6 to the 4x, you'd log base 6 of both sides. This is e to the 4x, so we have to log base on both sides.
Natural law.
You log base e of it, which is natural log. So what you're doing here is you're taking the log base e of both sides. There is.
Oh, wait, it's below the log button. Got it.
So 4x equals the natural log of 11 over 2. Again, it's going to give you some decimal equivalent. Natural log is log base e. All right? So you have to log base e on both sides. You just press natural log. Okay?
It's below the log.
So my final answer here would be x would equal 1/4 the natural log of 11 over 2. The reason I wrote it as 1/4 because I'm dividing by 4 repeats the same thing. I think you get
What is there plus the 4 and 3?
0.43. You okay on that? It looks a lot weirder than it really is. You're going to get weird numbers. Yes, sir.
how come you did times 3 for the first step? I kind of get where it came from, but that's
Just making it easier. Instead of working with fractions, get rid of them. Multiply by the common denominator. Stuff that we did when we worked with rational stuff, October-ish. Yes, ma'am.
Would you prefer if it were in that form or decimal?
Oh, I'm going to set the decimal. I just didn't have my calculator next to me, that's all.
Okay.
And this is a great idea, and I've been talking a lot of this lately in geometry when you're doing sines and cosines and stuff. Write down what you're about to put in your calculator before you put it in your calculator. Because if you wrote that down, 1/4 natural log of 11 over 2, I know you knew what you were doing. If you type it in, and let's say you type in your answer and you get a completely wrong decimal, but yet you show me what you did, you're okay. You just pressed the wrong button. I could probably figure out what you pressed. But if you just write down a decimal with no work shown and just picking out some numbers in thin air, I have no idea what you did. Take a second. These are easy problems. Write down the algebra before you put it in your calculator. What's that?
I said I have no idea what I did. I have no idea what I did.
You're okay.
I really do. It's true. I think about it.
Shouldn't you like set or something?
Same thing works. Oops. Back this one. When we have the same log bases on both sides. When you have the same log base on both sides, what's that? No, go ahead and say it. Yes. And here's the reason why. You could exponentiate them. Remember we talked about that?
Yeah.
It's not a word.
It is a word, and I'm going to prove it to you in a minute.
It's also a word.
Go to dictionary.com and show
If I put these both, turn those into exponents, 3 to the log base 3 allows that other chunk to drop down. Remember that?
Sure.
So that's why you can just set 5x minus 1 equal to x plus 7. Those were the properties that we worked with back in I think it was 8.4. And we did stuff where it was 5 to the log base 5 of x. You guys would say your answer is x. Because they drop. Yes, sir?
What if it's like log 6 to the 5x minus 1 and then log 3? Is there a way to...
Not for us.
Okay.
No. Not for us. You guys get 2? I don't remember it.
Yeah.
You guys got x equals 2?
Oh, I agree.
Add 1. Subtract 4, you get 4x is 8.
What happens when there are numbers in first log?
If there was a number out in front,
Yeah.
you'd have to be able to divide that out. And you'd have to be able to have some sort of a constant out there to make things work. You probably won't have a number out in front of the log when you have this type of scenario.
All right.
Okay, I wouldn't worry about that. Okay.
I'm just like asking every question I can, so like if there's no trick question or test or something.
All right, take a second. Oops. Look at this one. Log base 2 of the quantity x plus 2 equals log base 2 of x squared. Do you need to show the step that you're exponentiating it with a 2?
No.
No, you don't, because you already have the same log base on both sides. You have the same base on both sides, you get x plus 1 is x squared. Solve for x.
Oh, x plus 2 is x squared.
Thank you. Set aside equal to 0. Oh, come on, how hard is that?
I wasn't complaining. I'm
Oh.
trying to be positive today because I was a jerk on whatever last week was.
Some day that ended in Y. What times what is negative
Every
2
day that ends in Y.
that you add together to get negative 1? Negative 2 and 1.
And is this where we check for extraneous?
Absolutely. You should be checking for extraneous all throughout. But this one shouldn't be that bad, because what's negative 2 plus 2? Oh, hey, I don't know why I just wrote x. I forgot to write the x's in here. Sorry. I forgot to write the x values. My bad. I was wondering, I had put a parenthesis. I don't know what I was doing. That looks better. Sorry about that. So what's 2 plus 2?
4.
What's 2 squared?
4.
So log base 2 of 4 should equal log base 2 of 4, right?
Yeah.
Yes.
Okay. What's negative 1 plus 2?
1.
1. What's negative 1 squared?
1.
So it should work, right? They both work. Those will both work. All right. Sometimes they'll both work, sometimes they won't. Sometimes you'll get one of your answers from earlier that doesn't work. You just got to check them. It only takes a second.
I bet we're gonna have to like.
I don't even need this. This is too easy. Look! There's the word exponentiating. I told you it was real. It's in your book.
You all doubt it.
Just because a math book says it. Literally, our math book tells us that a letter I means that it's an imaginary number that doesn't actually exist. So that could mean the same thing by saying it's exponentiating.
True.
Nice some math.
Do you wear tinfoil in your head a lot too?
Sometimes. I actually have a selfie with my sister where we're wearing tinfoil hats.
There's more of you?
Yeah,
Older or younger?
both.
Oh.
There's one who never came to this.
Okay.
Lucky you. But
Now,
I
if
don't
you
know
look
if
at this
you'll
one,
ever make it to
notice the example notice the example here. I don't have a log on both sides, just have it on one side.
That was so much meaner than I meant to. She really is bad at that.
In this case, I have to get rid of the stuff in parentheses by the log base 5. In order to get that stuff out of the log, you have to exponentiate it.
It's 5 squared.
So what do you do on the other side then? You exponentiate it, so it becomes 5 squared.
There we go, I'll leave. Got one right.
So you get 3x plus 1 is 25.
What's 3?
You should get 8.
Oh, you just took 5?
Yep. It's not 5 in front of it. 5 becomes a base. Remember, we're exponentiating because we're using these properties. 5 to the log base 5, since those bases are the same, the exponent therefore drops down. All right?
How come before we were using log base 5, we were
Exponentiating.
In that case, we were showing them why that property works. By getting those both log bases, that's how they unbuilt both of them. And this is when when you actually really have to use it. Okay?
Wait, how come it isn't for like the 5?
Because 5 is the base. 5 squared.
Oh.
Okay? So, try that. Log base 2 of x is -1. Log base 2 of x is -1. You have to exponentiate it, correct? Okay?
Are you guys using that word? Put this wrong.
X is a half. Remember, think about what this is. Log base 2 of x is -1. 2 to what power, or excuse me, 2 to the -1 is? Half. Yes, sir.
Will it ever equal, it will equal like parentheses 6 plus x and you have to square it out factor from there?
You're not, no, because you're not going to have an x plus 6 on one side, because then you'd have 2 to the x plus 6 with your variable into another exponent.
Okay.
You'd wind up looping it back and around.
Okay.
Okay? If you get something like that, which is possible, it could be a no solution style, because you have to exponentiate log and back and forth, and it just goes.
I'm just asking everything, so there's no like trick questions or anything. Those always kill me.
All right?
Kill me.
Multi-step again.
Yay.
What?
You're making fun of me.
I know, I made it funny.
Oh, yeah. What? I told you to be mean to me.
It's not my forte.
I'm authorizing.
And the earlier
Yes, sir.
the 1/2
No, because think of it this way. 2 to the -1/2. No, because there's no base on it. Think about this. Think of the rules of log 2. 2 to the -1 is x. Going back and forth between log form and exponential. Sometimes you can do that. Yes, sir.
Do you have to move the 2 to the front to make it x squared?
No, it's 2 times the log, so you divide it.
Divide by 2, okay.
Yep.
Okay.
Wait, what?
Did I just say?
Yes.
Yeah. Remember, in this case here, every okay, subtract 15?
Yeah.
All right. So it's 2 times log, right?
So x equals 64. I told
Not
you,
condensate.
like, that out.
It's 2 times the log, so you divide it out, now you exponentiate it, right? Excuse me, sir.
Wait, I got x equals 0, I thought.
No. It's 2 to the 8.
Oh, it is.
And that's common. That's what a lot of people do.
I'm smarter than both of
Should be right.
But I still get it right if I do that.
No, because you got it wrong.
I just put it in my calculator.
Did you write it all out? I think you get X, it becomes 2 to the 8, was it 256?
Yeah.
Yes, ma'am.
I was right. Oh my god.
So
Wait,
I
what
did
do you-
things on your neck. I changed it to a log to x squared, and then I did 216. And then I got like x squared equals 65,536, and then the square root is 256. That still works.
It does, but it's cleaner this way. You're just using, because remember, what you're doing is you're working your way backwards.
I don't know what
You have 2 times something with an exponent. Get rid of the thing in front first. Because you'd have to divide out by, if it was 2x squared, you'd have to divide out by the 2 towards the square root. You know what I mean? Just working backwards off the order of op. Yes, ma'am.
Is this like kind of vision the calculator?
This would be a calculator, yeah, absolutely.
Because
I'm not
I can
gonna
do
do
2 to the 8.
Well, what's 2 to the 5th?
I don't know.
32.
And then you double it again, and then you double it. I mean,
You actually know what 2 is.
you can do that.
I barely know what the 2 squared is.
I was right.
Yeah, barely.
My number was the square root of it.
Let me find one more natural log one, and we'll call it a day.
I was still working. And Adrian still got 60. My number was minus 3 as well.
Wait,
I
the 2x minus 1 must be an exponent.
No, hey guys. What's that?
Was the 2x minus 1 meant to be an exponent?
No.
Not sure.
It would be a lot smaller if it was an exponent.
Yeah, it'd be smaller and be a little bit up above it.
Well, it's like, 1 to the 3rd of 2x minus 1 is 1/3.
Thank you.
X equals 13.
I do Wednesday, but that's about it. Like, I do nothing else.
I think you're the only one.
That's only like an hour of my time.
Oh, yeah.
Was that fish sauce?
Oh, what? Exponentiate it. Did you please get better at math?
That's my sister.
Armor or leg?
It's 14 guys.
Maybe. I said here.
I'm gonna guess you know how to read, so I'm proud of you. Once again, this is about as weird as some of these types of problems get. Notice you have 2 logs on one side. Whenever you have 2 logs on one side, you're going to want to condense. Okay? Create them as 1 log before you do the work.
Will you ever get to the problem where there are 2 different logs on one side?
You can't do anything with it. You just go to the next problem. So I can give you that, and all you have to write is no. I should.
I just do that for everything.
Now, in this case, if I condense it, I get log of 5x times x minus 1 is 2. Everybody okay with that?
Yeah.
How do you get rid of this log? You exponentiate it with the base of 10. Good. So now you get log, or 10 log of that, and it's 10 squared. Good, you're getting better. This side becomes 5x squared minus 5x is 100. What do you think you do?
Make a side equal to 0.
Make a side equal to 0? I agree. Now what? Pull out the 5. Why am I taking out the 5?
Because it's G.
Makes it easier.
Makes it easier, it's a GCF. Now, does this 5 have any bearing upon the problem the rest of the way out?
No.
So what are we going to do by it? Forget about it, but in essence, you're dividing everything. Divide everything by 5, and it goes away. It's okay. Wow. What times what's negative 20 you add together to get negative 1?
Negative 5 and 4.
Negative 5 and 4, good. Now, when you have your two solutions and you have to check these, well, you should be checking all along, you always check to your original problem. We have to go back to the original problem and substitute in 5s and negative 4. Now, if I use 5, log base 5 of 5 times 5 plus log base 10, log of 25 plus log of 4. When I do all of that, you hit the buttons and you get 2. It's crazy you did that so fast, y'all. I'm impressed. You had that telepathic property. It was, yeah. I tried. I know it was a joke. I was trying to call it pathetic, and it was sick of that. Sorry. Now, when you use negative 4, can you take the log of a negative value? No.
The answer's probably extraneous.
You cannot take negative. You can't take the log of a negative. You can't take log of negative 20. It doesn't work. No. But here's the thing. What if you went back to this step to substitute in? If you checked it at that spot with the negative 4, the negative would have multiplied out and became positive. And if you might. They're not. Because it's the condensed version of your original problem. It is extraneous. What I'm getting at here is whenever you're checking your answers, you always go to the original problem. You never go to anything that's been simplified out. That's the reason. Yes, ma'am?
So you can't have log 2 and negative 1.
No, because your calculator will say error.
Let's see what error it says.
It says non-real.
Shows the natural log.
Does it really say that?
Natural log. How do you undo natural log? You idiot.
Non-real
That's it.
answer.
Okay? Questions? Let's see, what page is this? 505. Let's do.
Today's Monday, right?
Yes, sir. This should not take long. This is really fast stuff. Don't forget, just check for your extraneous solutions, really. All right. We'll go over a bunch of these tomorrow. I got a couple other little ones I want to look at just to be on the safe side. But if you got any other lingering questions about logs or anything like that? Word problem stuff. Good times.
Mr. Murphy, if it makes you feel better, my sister's a lot nicer than
I look forward to being in this at some point.
you. You don't want to do that. She may be like for the answer, but you don't want to. She's 12, 6 years old. It's so scary because I threw a joke